Hello students, this is the continuation of chapter 1 Math Number System exercise 1.3. In this chapter we were discussing about rational numbers and irrational numbers. In this exercise we will study more about the properties of irrational number. I will explain it while doing the exercise questions. Question number 1. Write the following in decimal form and say what kind of decimal expansion each has. You are given some 6 questions. All these 6 questions are some rational number. You are asked to find its decimal form and you are also asked to write what kind of decimal expansion they are. What kind of decimal? First question, 36 upon 100. All of you know, without division, all of you know the answer of this question. 36 upon 100 is equal to 0.36. Now, what kind of decimal expansion is this? All of you might have studied in smaller class. This type of decimal is called terminating decimal. This type of decimal number is called terminating decimal. Division terminates. Division will terminate when we get the remainder 0. When you divide a number by another number, you can have 2 types of answers, 2 types of decimal numbers. One, after some time, the division will get terminates. The division will get terminate when the remainder becomes 0. When the remainder becomes 0, division is over and you will get an exact number as its answer. This type of decimals are called terminating decimal. There is no other digit after 3 and 6, 0.36. The answer is complete, the answer is stopped there. So this is called terminating decimal. Question number 2, 1 upon 11. 1 upon 11. Now let us divide 1 upon 11. 0.09. Again the remainder is 1. When the remainder is 1, you know, again these things will happen. In every step, you can see the remainder is 1. So whenever you get the same remainder as above, you have to stop the division there. If the same remainder is repeated in any step of division, the division can be stopped because you are going to get the same answer as you got previously. For example, after 0.09, you got the same remainder again 1. So, the answer will be same 090909 infinitely. So, whenever you get the remainder same as any other step above, no need to continue the division. Stop there and see what is the answer before. The same answer will be continued infinitely. So here the first answer is 0.09. Then again the same remainder 1 is continued. So the answer will be 090909 infinitely. So the answer is 0.0909 dash dash dash, or you might have studied in smaller class. This can also be written as 0.09 bar. This type of decimal is called non-terminating non-terminating recurring decimal. Non-terminating recurring, or it is also known as non-terminating repeating decimal. I repeat, 0.0909 dash dash dash. Why did we put this dash dash? Because in every step we are getting the same reminder, so the answer will be repeated infinitely. So the answer is 0.090909 dash dash, which can also be written as 0.09 bar. This bar indicates the digits under the bar will be repeated infinite number of times. So this number is not going to terminate. So it is called non-terminating. But in the answer you can see 09 is repeating several times or infinite time. So it is called non-terminating recurring decimal or non-terminating repeating decimal. Now you have 4 more questions given in this question number 1. Everywhere you are given some numbers which are in rational form. So now we can conclude the decimal form of any rational number can come in 2 ways. Number 1, either it will be a terminating decimal or it will be a non-terminating recurring decimal. This is sure. The decimal form of any rational number will be either a terminating decimal or a non-terminating recurring or repeating decimal. Is it clear? Now, there is a third type of decimal number also, that is called non-terminating non-recurring decimal. Non-terminating non-recurring decimal. Such non-terminating non-recurring decimals are called irrational number. So in question number 1, all the questions are rational. So your answer will be either terminating or non-terminating recurring. I am not telling this in connection with question number 1, but I am telling you there is a third type decimal also, which is called non-terminating non-recurring. That means that decimal will be non-terminating. It has no end, but no digit will be repeating there, or you cannot express that decimal with a bar sign. This bar is possible only in such decimal where certain digits are repeating. So above that repeating digit we will put the bar. I am going to show you a number which is non-terminating non-recurring. For example, 7.0112 dash dash dash. This type of number is called non-terminating non-recurring. You can see the digits appears to be same 0, 1, 2, but it is not repeating in any pattern. Here only 1 is increasing, but not 0 and not 2. So we cannot put a bar above any digits in such numbers. Another example, 5.233 dash dash. This is also a non-terminating non-recurring decimal. So decimals are 3 types: terminating, non-terminating recurring, and non-terminating non-recurring. All the terminating decimals and non-terminating recurring decimals belongs to rational number, but all the non-terminating non-recurring decimals are irrational. I told you in my previous class, root 2 is irrational, root 3 is irrational, root 5 is irrational. Now, if you check the decimal value of root 2, root 3, root 5, root 6, root 7, etc., everywhere you can see the answer will be a non-terminating, non-recurring decimal. Try to find out the answer of root 2 as a homework today. In class 8, you have studied the method how to find the value of root 2 by long division method. By long division method, try to find out the value of root 2 today. And you see whether your division ends or not. And you see the answer. Is that answer terminating or non-terminating recurring or non-terminating non-recurring? I am telling you the answer in advance. You will get a number which is non-terminating non-recurring. So please do the remaining questions of question number 1 as homework. Now see question number 2. Question number 2. You know that 1 upon 7 is equal to 0.142857 bar. Given 1 upon 7 is equal to 0.142857 bar. Question: can you predict what the decimal expansion of 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7 are without actually doing the long division? If so, how? You are given the value of 1 upon 7. Now we are asked to find the value of 2 upon 7, 3 upon 7, 4 upon 7, etc. without actual division. Using this value, we have to find the value of 2 upon 7. Yes, we can. We know that 2 upon 7 can be written as 1 upon 7 into 2. 2 upon 7 can be written as 1 upon 7 into 2. Now what is the value of 1 upon 7? 0.142857 bar into 2. Now do you know what will be the answer? Multiply 7 into 2, 14. 1, 7, 5, 8, 2. The answer is 0.285714 bar. Simply you may multiply this number by 2. You will get this. 2 multiplied by this and then put a bar. The very interesting thing is that look at the digits above and below. This is 142857. This is the same digits but in a different order. 285714. Same digits are same. See, 142857. Now, what will be the value of 3 upon 7? 3 upon 7 can be written as 3 into 1 upon 7 is equal to 3 into 0.142857 bar. Multiply. See, now we got the answer 0.428571 bar. 42857 bar. Now if you continue with 4 upon 7, 5 upon 7 and 6 upon 7, your answer will contain the same digits but the order will be changed. So this 1 upon 7 is a very funny number in algebra because in 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7, the answer will contain the same digits but in different order. Now question number 3. Now see question number 3. Express the following in the form of P upon Q, where P and Q are integers and Q not equal to 0. All of you know P upon Q is the standard form of rational number. So you are given some numbers in decimal form. And what decimal? All the given questions are non-terminating recurring decimal. And we have already studied all the non-terminating recurring decimal numbers are rational numbers. So rational numbers can be expressed in two forms, either P upon Q form or decimal form. Question number 1. In question number 1 we have seen when rational numbers were given in P upon Q form, by division we have converted them into decimal form. Then you got two type of decimal. Now just opposite. You are given 3 questions here which are in decimal form, but all these decimals are non-terminating recurring. Now we are asked to convert them into P upon Q form. Listen carefully. First question is 0.6 bar. .6 bar is a non-terminating recurring decimal. So this is a non-terminating recurring decimal. Now we are going to change it into P upon Q form. See, the first step, let the given question be x. So let x is equal to 0.6 bar. Keep it as equation number 1. Second step, always see how many digits are under the bar sign. Here there is 1 digit under the bar sign. If there is 1 digit under the bar sign, multiply the whole equation by 10. So, equation 1 multiplied by 10 gives 10 into x, 10x. 0.6 bar into 10 will be 6.6 bar. Do you know how? 0.6 bar means 0.6666 up to infinity. When we multiply this by 10, what will happen? This decimal will shift to one side rightwards. So when this number is multiplied by 10, decimal will shift one place to the right. So it will become 6.666 up to infinity, which is same as 6.6 bar. So when 0.6 bar is multiplied by 10, the decimal place will move 1 to the right, so it will become 6.6 bar. Now keep it as equation number 2. Now you can see in question number 1 and question number 2, after the decimal, the bar part is same. Here it is 0.6 bar, here it is 6.6 bar. If once the bar part in both the equations equal, we can eliminate this 6 bar part. We can remove this 6 bar part. How? By subtraction. Now, below this second equation, I am writing down again the first equation. X is equal to 0.6 bar, which is equation number 1. Now, I am going to subtract this equation from this equation. Equation 2 minus equation 1. How can we subtract one equation from another equation? By changing the sign. 10x minus x, 9x. 6.6 bar minus 0.6 bar. 6 bar got cancelled because they are same. 6 minus 0, 6. 9x equal to 6. Therefore, x is equal to 6 upon 9, or by cancelling it becomes 2 upon 3. See, the answer is in P upon Q form. This is the method of changing a non-terminating recurring decimal into P upon Q form. All of you see once again the steps. I hope it is clear to all of you. So first step, let the given question is x, equation number 1. Then count the number of decimals under the bar sign. If it is 1, multiply the whole equation by 10. If there were 2 digits, we would have been multiplied by 100. If there are 3 digits, we will multiply by 1000. While doing so, the bar part in both the equation will become same. That bar can be cancelled by subtracting the 2 equations. When the bar is removed, you will get the answer in P upon Q form. Now see its second part. Question number 2. It is 0.47 bar. 0.47 bar. But this time the notable thing is that bar is only above 7. After the decimal, there is 1 digit without bar and bar is just above the next digit, that is 7. In this also, as I told you earlier, first step is let x is equal to given question 0.47 bar. That is the equation number 1. But now there is a change. If the decimal is after the decimal, if the entire thing is not in bar, we have to make it. Means after the decimal, we require only bar on the right side of it. So how can we make it so? If the decimal moves 1 place to the right, it will become 4.7 bar. Then after the decimal, there will be only bar. So for making it 4.7 bar, what is to be done? Multiply equation number 1 by 10. 10 into x, 10x. When we multiply it by 10, it will become 4.7 bar. It is equation number 2. Now this has become in the form of our previous question. After the decimal, there is bar sign. Now count the number of digits under the bar. 1 digit. So once again we have to multiply this equation by 10. So now equation 2 multiply by 10. 10 into 10, 100x. As I told you in the previous question, when we multiply it by 10, the decimal will move 1 place to the right. So it becomes 47.7 bar. This is equation number 3. 7777. While multiplying by 10, 1 7 will come before the decimal. Now you can see 7 bar is common in both the equations. So write down the above equation, that is equation number 2 below equation number 3. And then subtract. This time equation 3 minus equation 2. 100 minus 10, 90. 7 bar cancel. 47 minus 4, 43. Therefore, x is equal to 43 upon 90. This is the answer. So remember, if the bar and the decimal are not together, then first of all we have to multiply this equation by any such number so that after the decimal there must be bar sign. Then continue as we have done in the previous question. Now there is one more question. Third part of this question is 0.001. It is very easy. 0.001 bar. Here, after the decimal, the entire thing is under the bar. So, We will begin from this step. Keep it as, let x is equal to given question, equation number 1. Equation 1 multiply by 1000 because there are 3 digits under the bar. So equation 1 will be multiplied by 1000. Decimal will move 3 places towards the right. It will become 1.001 bar. Equation number 2. Now from equation 2 subtract equation 1. Next question, question number 4. Express 0.99999 dash dash in the form P upon Q. 0.9999 dash dash in the form of P upon Q. Question continues. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. Are you surprised by the answer? So let us see the answer first. Then let us discuss, are you surprised or not? So as usual, let x is equal to 0.9999 dash dash. 0.9999 dash dash can be written as 0.9 bar. So this is equation number 1. Since there is only one digit under the bar, we will multiply equation number 1 by 10. It becomes 10x is equal to, decimal is shifted one place to the right, it will become 9.9 bar. This is equation number 2. 0.9 bar, 0.9 bar. Both the bar parts are equal. So 2 minus 1. Write down equation number 1 below it. 0.9 bar, equation number 1, and subtract. Equation 2 minus equation 1. 10x minus x, 9x. 9 bar got cancelled. 9 minus 9, 9. 9x equal to 9, x equal to 9 upon 9, x equal to 1. Now see the answer. Our answer question was 0.9999 dash dash, and all of you know 0.9999 dash dash is less than 1, a little less than 1. But what if we get the answer here? X is equal to 1. In P upon Q form, the answer is 1. But the actual question was 0.999, which is little less than 1. So, are they exactly equal? Are they exactly equal? No. This is little more than what was the question. So, what can we conclude from it? The P upon Q form of a non-terminating recurring decimal is not actually exact. Both of them are not exactly correct. It is the most appropriate nearest form, but not exactly equal. So in order to prove this part, this question was given. While converting decimal form into P upon Q form, both the answers will not be 100% same, but it is the nearest approximation. So we can conclude P upon Q form is not exact, but actual exact form is decimal form. So the non-terminating recurring decimals, when converted into P upon Q form, the answer, both the values need not be 100% same. Okay, that's all for today. Now there are some more questions left out in this exercise that will be continued in my next video. Please practice.